The following content has been provided by RWTH Aachen University.
Today, we're going to continue the discussion of some psychological fundamental laws and guidelines that help us design good user interfaces. And we'll touch on topics such as Gestalt Laws, a set of interesting psychological rules that govern how we perceive our environment and how we cluster it into units. We'll talk about information content because we can actually measure, in the Shannon sense of the way, the information capacity in bits for an information channel between the user and the system. So what's being output or even what you are inputting into a system. We'll talk about visibility, one of the key features of good interfaces that show the user what to do and how they can do it. And we'll introduce a concept that will help you a lot to understand why people are tempted to do certain things when they first interact with the system. And this is governed by the concept of affordances, which basically describe what are the things that a user interface suggests to the user to do with it. And signifiers are closely tied in with affordances, and together they define this kind of like, natural things that an interface suggests you can do with the system or you cannot do with the system. This is also directly diving into Don Norman's book, The Design of Everyday Things, which I hope you all managed to get a hold of by now. And you should definitely get it and start reading, or already have started reading if you haven't already. We'll go through this again at a swift pace. And so keep up with reading this on the side. It's not tough to read, but it does cover these things in much more detail than we're able here to do this in this class. Okay, before we do, a very quick review on what we talked about previously. We talked about the 4 big areas of HCI. If you remember that graphic, there's the human, there's the computer, and of course, questions about human psychology come into play. Questions about how computers technically implement user interfaces come to play. And then there's the area of the design process and the development process that contain things as prototyping techniques, evaluation techniques, but also case studies, like the things that we talk about in our history, so-called history section. And then we have a 4th area, that's the context of use, which is something that separate lectures such as CSCW by other colleagues at our university cover in more detail. Okay, the second thing we talked about was the Cmn model. Just as a quick refresher here, you'll remember the main components of the Cmn model, the 3 processors that are associated with humans processing incoming information and reacting to it. There was the perceptual, cognitive, and motor processor, and we had some key numbers attached to this model. First of all, the cycle times of each of these processors, meaning what's the minimum time each of these processors needs to do one step of information processing. And we found that these were 70 to 100 milliseconds, depending on the processor, on average. Right? All these numbers are, of course, average numbers, and they can vary widely among people and even within a certain person, depending on time of day and their current condition. And also associated to the Cmn model, of course, is memory. Processors can't do much without memory. So the Cmn model models the human brain as having some working memory, short-term memory, if you like, that has some visual and audio image stores. And then it has long-term memory where we store things for later retrieval. And some of the things that you should remember here are the pretty limited capacities of short-term memory, right? They're not huge. Remember those number experiments we did when you had to count backwards and or like remember a number sequence read to you. So these are important to keep in mind because they show us what the human brain is great at and what it isn't so great at, and how we can roll this into designing the user interface. And then finally, we talked about Fitzlaw, a super useful principle that actually has way more applications than you might initially think. It's not just about a user tapping a key on a keyboard and measuring how long that takes based on the distance to the key and on the size of that key. but it also applies to a lot of other interactions when people try to grasp things in space. And there have been lots of extensions of Fitzlaw, both to new input devices. For example, if you move from the hand to the mouse, that's a different input device, and you need to recompute those parameters in Fitzlaw formula by running experiments and finding those parameters. And also different contexts of use, like mobile interactions, for example. So Fitzlaw, to this day, even in 2021, you will still see papers at Hci that try to extend Fitzlaw and apply to a new area that you might not have expected it. And it seems that it's a pretty fundamental law about how the human motor system works. And I think in the lab, right, Ollie, we link Fitzlaw to the Cmn model actually and show that they're actually both kind of the same thing.
Actually, we don't do the derivation anymore.
Oh, you don't have that in there right now. Okay, we had this in the past years. There's a nice little one-page mathematical deriving of Fitzlaw that shows that it actually works the way that it does work in this logarithmic fashion because of the nature of the human Cmn model processor. Yeah, if that's not in the slides yet, we'll definitely catch you up on that next time. Okay, so we will start you guys out with a very, very quick exercise here. So get out a piece of paper and a pencil and start sketching a universal remote for 3 devices. And we picked some kind of, vintage devices here for a reason. So this remote should be able to control a radio, pick a station and stuff like this. It should be able to let you control your TV, and it should be able to let you control your DVD player, okay? So 3 old physical devices that and a physical remote we're talking about here, not an app, and not, streaming services, anything like that. So 5 minutes, go and have fun designing this. Okay, so we won't be discussing your design right now. And first of all, that's kind of hard with 124 people in the call right now. But also, this was really for you to do sort of an unspoiled attempt at designing this interface from what you think, is our good choices right now off the top of your head, because it sounds pretty simple, right? We've all seen many of these devices, and you'll probably have, adopted or copied some of the designs you've seen yourself. And what we're going to do now is talk about a few laws governing human perception interaction with technology. And after that, we'll reflect back on your designs, and we'll give you a chance to revisit them, applying the knowledge that you've gained. Okay, that's the idea behind this. So your design will have some flaws. Nobody designs a perfect interface in 5 minutes, not even if it was a single device remote. So we'll get back to this later. For now, we'll jump into the first section of psychological rules, and this is Gestalt laws. Now, Gestalt laws are rules that tell us how people make sense of their surroundings. And people are really good at this. Our brains are literally wired to make sense of what we perceive, right? This is really how our brains work. And we're optimized for this. So can anybody tell me what you're seeing in this picture? You can just unmute and shout it out if you see something.
It's a dog sniffing at something?
Yep, there's a dog right there, right? And so you've probably picked up the dog there. If you haven't picked up the dog, that's totally fine. Some people see it, some people don't immediately see it. There's even a tree back in there in the background. So this was a heavily obviously photoshopped image, but we pick up the dog. Now, what you'll also notice is if I remove this highlight again, it's really hard not to see the dog, right? It's basically, you've now seen it, and it's almost impossible to unlearn and take those dots as what they are. There are more examples, of course, of this, of the brain making sense of pictures. Anybody can tell me what you're seeing here? Again, you can just shout out if you see something.
Someone riding a horse.
Yeah, there's some. Yeah, that's the rider on a horse, right? Again, you may see this, you may not see it. Lots of examples like this, two people facing each other, or maybe this is just a chalice, a vase of some kind of thing. Or I'm sure you've seen this one before. This, depending on how you look at it, could be a young woman looking away from you with the in the profile, or it could be an elderly woman, with a big nose and a shawl around her head, looking at you. If you look at these carefully, and you can sometimes even make it flip around, right? Try to look at it from both sides and see both effects. So all these things, there's more of these. For example, here, I'm sure most of you are just seeing a couple dolphins swimming around. But if you're not, then that's fine too. Again, there are two things here, two ways to interpret this picture, and our brain will latch on to one or the other. So this ability to make sense of what we perceive is crucial for interface design. And don't get me wrong, this is not, I'm not saying, you should make your interface, so that it only reveals itself after seeing these hidden patterns, right? That's not the point. The point is, this is just there, right? Whatever people see, they will start making sense of it. And that's a blessing and a curse. If you apply the rules that we're about to cover in a good way, you're going to have a great interface. And if you apply them in a bad way, if you don't pay attention to the rules being there, then your interface is going to be hard to use. So the rules always happen because this is how people perceive, right? You can't not have an interface follow these rules. The rules always are in effect. It's just a question, are you making use of that fact? So this is covered under the topic Gestalt psychology and Gestalt laws. These rules were originally combined and expressed by a group of 3 psychologists, Köhler, Kofka, and Wertheimer, from the Berlin School of Psychology. And this was in 1912, so this is more than 100 years old. But I told you before, the brain doesn't get updated every year with new versions, so guess what? Those rules still apply. And all the laws, and this is important to keep in mind, all the laws answer the same question in a fundamental way. What do we as humans perceive as a group spatially? Or maybe temporally, meaning things happening in sequence when we do perceive those as a group. But mostly we'll talk about spatial because the visual part of the interface is so prominent in our work. So what becomes sort of united into one when we look at things? How do we cluster things into groups? And these rules don't just apply to how we see and make sense of things around us, but they also, by consequence of this, govern how we move, how we memorize things, how we think about the stuff in our world, how we learn, and even how we act. So these are quite fundamental to how our brain works on a very basic level. And there's more than 100 Gestalt laws in the work by these 3 scholars, but we will only touch on a very few that are especially meaningful and easy to see how you can make use of these laws that exist in your user interface design.
Gestalt laws are simple rules which help us to make our user interfaces very simple and to make them understandable and parsable very quickly. So when you apply those correctly, you can give a user an interface and he immediately knows what of those visual things that there in the interface belongs to what another thing and what actions. So for example, if you look here on the right on the image on the right, I think no one of you will have problems to match some labels and icons together, or to see that there are 3 different regions in this one window, or even you won't have any problems to see that some icons and labels and so on belong to the most front window and not to the one which is in the back. And this is because some Gestalt laws apply. So let's start with the first one. So usually when this wouldn't be an online class, but it would be an presents class, we would do an in-class exercise here. And I would give you the shape on the left side. And I would show this to one of you for around 1 second, then hide the image again and let you draw the shape. And after that, we would do the same with another student and with the drawing from the student before. And maybe you can already think about what will happen in the end. At some point, the drawing will get more and more simple, and we reach something in the end which looks at least like a circle, because to be honest, only a few people can draw perfect circles. And this is the Gestalt law of good shape here, because what happens is that our brain cannot save the exact shape of what you have seen before. Instead, we try to find a level of abstraction which helps us memorizing these things. So instead of saying, yeah, we have there a path which starts in the top right and goes down, goes 3 centimeters to the bottom, and then there is a hill going 1 centimeter up. We just say, yeah, it's a circle-shaped thing with some hills and some bumps into it. And Jan said at some point that Gestalt laws are about grouping stuff. And this is true for most of the laws you will learn. However, the Gestalt law of good shape is rather about just making you aware that we simplify things in our brain. We have, you see here on the slide, the cognitive compression algorithm in our brain, which makes things easier for us to remember. But when you use this Gestalt law and use simple shapes in your UI, it's definitely easier to process for the user. So you should definitely remember this. When we now look here at this image, if you would have to describe to me what you see here, such that I, without knowing this, could draw this, what would you say?
2 set of parallel lines.
Exactly. You would say, okay, we have 2 lines on the one side, we have 2 lines on the other side, and those are parallel. And what you have done directly is you grouped things together. So you said the 2 lines which are close to each other are one group, and the lines on the other side, which are also close to each other, are the second group, and the other ones have, and in between those 2 groups, there is a distance which, breaks a connection you could have there. So this is the Gestalt law of proximity, which simply says objects which are near each other are perceived as a group. And this is a very, very, very powerful tool you can use. If you remember the image with the windows before, you have seen we had icons and we had labels, and the labels were very near to the icons, such that you know, okay, this label belongs to this icon, and altogether this is a button you can click. And applying the Gestalt law of proximity leads you to have a very clean UI, because you don't have to create boxes to put things together and so on. You can simply just use proximity with any other visual aids. And by the way, sometimes those things can also work out pretty bad, because if you look at this example here, this is something we found at Informatikzentrum, so here in Aachen, in front of our Mensa. And unfortunately, the image is in German, but the sign there on the top, on the right says, check your payment card here. And this is placed on top of a fire alarm. So we really hope that people do not just rely on the Gestalt law of proximity here, because otherwise, this would be a very, very expensive mistake. The next Gestalt law is shown here, and here this is an example where you first of the time see that multiple things can apply, but some Gestalt laws are a bit stronger than other ones. So what would you say? What do you see here?
3 boxes.
Exactly. But if you remember the Gestalt Law of Proximity for some seconds ago, probably, we have seen the same lines, and we have seen that there are some close to each other and some not, and we have grouped them totally differently. Here in this example, we have those boxes consisting of 4 lines, but the fact that those lines form a shape. Sorry, yes? Okay, it was an accident, I think. The fact that those 4 lines form a shape, the rectangle, we perceive those 4 lines as belonging together, although we also have lines which are close to each other, which would be grouped together if we only would have the law of proximity. And this Gestalt law is the Gestalt law of closure. So closed lines appear as shapes and thus belonging together. And this is more or less what we always use in our operating systems. We have windows in our operating systems which are more or less just built up of 4 lines, and the fact that they are forming this shape, we think we perceive them as being one thing, as one window, as one entity. So here another example. To be fair, one has to say that modern UIs, of course, try to make their designs a bit nicer looking, and thus we have here also round corners and so on. But nevertheless, we see here the rectangle as shape, and thus we see this as one entity. Very similar, what you see here is that we now have 3 boxes and some dots inside. But before I continue, I see there was a question.
Yes, Oliver. Am I audible?
Yeah, I can hear you.
Yeah. So is it possible that 2 Gestalt law conflict each other? So in a sense that sometimes when I see a pattern on a T-shirt, let's say like really small boxes, the brain starts to oscillate between 2 different perceived images.
Sorry, I did not understood your last sentence.
In a way, let's say there's you have something like 9 boxes, right? So sometimes I don't know if that has happened with you. It has happened with me that when I see some pictures, some shapes on a shirt, I start to visualize 2 different shapes. So let's say crossroads and a box within a second, something like that. So that is really hard to see. That pattern is really hard to see. So is it possible that 2 Gestalt law conflict, something like that?
Yeah, so definitely Gestalt laws are very often also used in an for art and so on, to confuse people, to make things, to create illusions and so on. So definitely it's possible that those Gestalt laws are used to create different perspectives on things. This is more or less the same we have seen before with the vase and the horseman and so on. So at some point, or with the old woman and the young woman, you can definitely see the one thing, but at some point when you really just focus on this, you can see the other thing. And nevertheless, I would say, and I would say,
what I was saying was that, I do understand, but what I was saying that the duration with which I perceived that second shape is really small, within milliseconds. So I think my brain is somewhat oscillating between those 2 images, which really makes it hard for me to see those patterns.
Yeah, exactly. And if I'm pretty sure that when you remember the woman, there was the one thing you have seen directly, and to see the other thing, you really have to focus. And nevertheless, I think you have a preference for one of those versions, and I think the same applies here. And this is because different Gestalt laws apply on different ways for people.
Okay, okay. Thank you.
No problem. If someone of you is still unmuted, please mute again, because I had some noise, additional noise. Okay, continuing with this Gestalt law. So what we have here is we have the boxes, as you have seen before, which create for us a group, as we have already said. And what we see is that there are dots inside those boxes. And I think if we continue thinking about grouping, we would definitely say the 3 dots in the first box is one group, the 5 dots in the middle one, and the 4 dots in the white box are grouped together. However, again, now if we put those boxes away, this grouping might be gone for you. So what I, for example, see is, for me, as groups being grouped together are those 4 items here. If you see my mouse cursor, I hope so. Or what also was reported to us, that people group according to horizontal lines. So we have the 3 lines in the first row, we have the 4 lines in the second row, and so on. So what happened here is what we call the Gestalt Law of Common Region. So if you have a region, however this region looks like, and elements are inside this region, those elements are grouped together for us. So for example, here we use the boxes we understand as region to group the dots, but this can be also different things. For example, color or texture of what you see. This is applying for many things. And also here, again, this is very helpful for us when we think about our operating system and the windows we have, because all of a sudden we have the reason why a button within a window moves with the window, because we perceive this window as one region and the button is inside this region. Here is, unfortunately, the example that you also can overdo all those Gestalt laws. So what you see here is an example from Johnson's GUI bloopers, definitely a book you can have a look at. And here you definitely see one can overdo using boxes and yeah, the Gestalt law of common regions. It's a very visually cluttered interface, and to be fair, I think if we just remove those boxes there, we would still know what text field belongs to which title there, because of the Gestalt Law of Proximity. So here you definitely see that Gestalt laws, if you apply them correctly, they can help making interfaces easier and look cleaner. And at sometimes you are, but at sometimes you always also have to look that you don't overdo some stuff. Okay, what do you see here?
William signs.
Sorry? Can you repeat this?
3 geometric shapes.
You see 3 shapes. And this is again a form of grouping here. So you said we see 3 shapes, not one line with 3 shapes and another line with 3 shapes. So different lines with different shapes, but you grouped by the similarity of those shapes. And this is exactly what the next Gestalt law is about. It's about similarity. So shapes which are which look similar are grouped together. So here we have the 3 triangles, we have the 3 circles and 3 rectangles, and this helps us parsing the interface. And as soon elements which should be similar look differently, this makes it a more difficult to parse for the users and make the interface harder to understand, and increases the cognitive effort. you can use this Gestalt law in many ways. So having, for example, buttons look the same as an element on your UI which performs an action is definitely a good thing. However, some buttons you might want to have look different. And maybe you can see this a bit more in the next example. So what we have here is a very old application, to be fair. It's about accessing newspapers in the early days of digital media. And when you now think about this interface, what do you think? What is a problem with that?
The buttons are all look similar, even though they have very different levels of importance.
Mm-hmm. The buttons look very similar. Yeah, Marco?
Yeah, they're also just like basically just like clustered one after another. And in a way, I mean, to me at least, it seems like they're not necessarily, let's say, clustered for similar functionality. For example, I don't know, like I would put exits completely at the ends and quit as well, for example, whereas checkpoint, I wouldn't put it next to exits because they're completely different, for example.
Exactly. So the buttons look very same, and also buttons, we would say they have similar actions, which we would group at least together, are far away. For example, as you said, the quit button and the exit button are far away. And also here, when we talk about similarity, I think it is dangerous that the read button looks similar like the quit button, because you might confuse them and accidentally click on them. And if the quit and exit button would have, for example, a different experience, you can definitely you can avoid mistakes of the users. By the way, also here that you don't have this visually cluster. So for example, by applying the Gestalt Law of Proximity, it's very hard to find the different functions in this interface. Okay. I see some questions in the chat, but I don't think. Things like this will also be handled in some way in DIS2. Definitely worth looking at the content there. And for the rest, you can discuss this in your groups, I think. Okay. Does someone want to explain what we see here? Yeah, Janosch?
I would say we have one diagonal line with another kind of crossing curved over it or curved through it.
Exactly. And again, here you see how we group things together. We have, well, what applies here is the law of continuity. So instead of saying that we have, 4 lines which meet at some point in the end, we say we have 2 lines because the line continues on the same way as it did before. So we had here a very straight line, and then it followed by another straight line. So we say, okay, this should be 1 line, and we have here a curved line with the same slope at this point here. So we say, okay, this belongs together. And this is the Gestalt Law of Continuity, or the Gestalt Law of Good Curve, and says that continuous shapes appear as belonging together. And this is, by the way, something you can use when it's about alignment of elements in your user interface. The next question, what do you see here? Yeah, Janosch again.
I would say sideways uppercase E.
Exactly. So again, you have here at least 4 lines, maybe 5, however you want to see it. But how we describe it is it is an E which lies on its back. And this is because of the Gestalt Law of Experience. So we connect those lines into a concept we already know from our experience, and we know the E, and thus group those lines as one entity as being an E, in this case, laying on its back. And the aspect that it's laying on the back also sees how strong this is, because we can still make variations in those concepts and still describe it very easily. Yeah, Marco?
Could there actually be a problem with this law? Because some people might see something different. For example, the first thing that came to my mind was, for example, two, let's say, classes somehow fitting together. Or also what I was thinking of is Cyrillic alphabet has a similar letter, yeah, which is like sh letter. So
this is this is definitely true. So people with different experiences with different contexts see different signs here. So you always have to be aware what you try to use here. But on the other hand, you have, when it's about user interface design, you have always also to think about that those symbols should match the context you are using it. For example, if you find this in an for this symbol, I don't have an example in my mind at the moment.
Use it as a scale.
For example, if you have something scale-like interface, maybe an AR app with where you can measure your room or something like this, this symbol definitely, you will more match this to the scale of what you have. We have your physical ruler or something like this. So you should always be aware that those signs can be misinterpreted and make it as self-explanatory as possible. At some point, however, if you use symbols which are already connected by the experience of most users, then this makes parsing your interface very easy. A simple example for that is the controls of your music players. Therefore, example, for skipping to the next song, you have those those two triangles showing at one side. And for you, probably, this is one symbol, right? This is the next song symbol or next playlist symbol, instead of two triangles. So using this Gestalt law, you can make wisely, you can make your interface explainable, for example, also without labels. So you don't need a label to describe what this button is doing. And this is also then helping you doing creating metaphors and using metaphors, for example, for buttons. So very often you use cloud symbols with arrows to the showing to the button to make understand that you are downloading something from the internet. So this is helping doing things like this. Okay. I hope you see the animation here and it's not too small on your screen. Nevertheless, what you see here is that we have one static noisy image here, and in the bottom you see something moving. And as you see those points which are moving, they look completely different, but they are moving the same. And for this reason, we group them again together. So this is the Gestalt Law of Common Fate. So objects which are moving together, especially in a static environment, appear as a group. And those animations can have a very, very, very strong effect, as you have seen, for example, here in the image. And this is also something you see in many presentations and animations when things just move together. You see that the context stays the same. And unfortunately, as it's always the case, people can make very misuse of this Gestalt law. And what we see very often is that things try to get our attention by by using animations and making things blinky, for example. And to be fair, we have to say those blinking words are, again, for us, the blinking words, a group, and perceived as such that, and the other words which are not blinking are the other group. And for sure, you can also do this in many other ways. Okay, so having this microwave here, maybe we can collect some Gestalt laws which are applying here.
The law of similarity and region for the numpad.
Exactly. So in the numpad, you have those little small buttons which all have the frame around this and the number inside this. So those look similar and do the similar thing, which is entering a number. Something else?
Law of closure as well, because of the boxes, I guess. Because of 1 and 2 boxes are really close. The lines are really close, but since it is in an enclosed shape, we perceive one as a whole shape.
This is too much. Please, one after the other. So Gestalt Law of Closure is applying here everywhere. I did not perfectly understand you, but I get the most important stuff. So that you have the lines on the top, on the right, and the bottom on the left creates this this interactive this input device for your microwave. Also for the buttons, the Gestalt Law of Closure is happening to have those, to create those boxes, and are perceived as boxes and further than as buttons. Gestalt Law of Closure is applying everywhere here. Something else?
The law of proximity, but it is a bit confusing. I'm not sure if the handle opens the microwave door or if the button below. So
this is a good point, but why do you think the law of proximity is applied here? If you are speaking, you're probably muted.
So with the handle, it seems like it's inside the numpad region and it's belonging with numpad instead of with the door. And the same is happening with the button below. So I'm not really sure which one connects to the door.
This is a very, very, very good point. So if it's about proximity, one would have to say that probably the bottom one is closer to the door, but I would also support that this is still very not clear here in this case. However, the thing on the right, you are right, this looks like a handle, right? I'm pretty sure most of you have no idea what this is really about, because this is a light pen with which you can scan the barcode on your products such that your microwave has the correct parameters for heating the product up. And this is the very confusing part, because the first attempt of many people here would be to grasp this thing, to push this or something like this. And this is how the point where also the Gestalt Law of Experience applies, because it looks for us like something we connect to a handle, or at least to a button. And this makes this a bit difficulty in this case. Okay, many questions, or at least ideas for Gestalt laws. Then Serine, and I hope I pronounced your name correctly.
Yes, I wanted to add, I think someone mentioned the law of closure regarding the buttons. I'm not sure if they meant the overall interface, that's basically that the law of closure was applied there, or if they meant the buttons. But I wanted to I guess add a critique point in this place here because I was kind of confused at first when I saw the round buttons that are connected, like defrost, scan, and stop, cancel, add a minute, because I find although they're kind of grouped, so you initially assume that they have similar functions. It is, in my opinion, not the case. So I would probably group start and stop and cancel together, but I understand why they probably made start like stand out more because it's a primary function, I guess. But yeah, I find in this case, closure is probably not correctly used.
Exactly. Well, the thing is about closure. I think you confused some of the Gestalt laws. So you were talking about things looking similar should do similar actions. So start and stop are something you would connect together. You say that they should should look similarly and should be also connected by. I think you suggested putting this here, for example.
Yeah, especially if they're like, for example, the number pad, you know, okay, so that these all of these belong together because they're grouped together and they look similar. And so the case does not apply to the other ones.
Yeah, for start and stop,
so,
this is not
also
happening.
similar looking and grouping. That's that was my point.
Yeah. So what happening is they can be grouped together, but they don't look similar. So the Gestalt law of similarity is not applying. And we could say that we want to have them in the same region. So for example, as you said, those two, you don't think that they belong together. Nevertheless, they are in the same region. They are in this weird round shape here with two circle shapes. By the way, you see, you should use simple shapes such that I can talk about them. Yeah, definitely. So if you you're right, they made this thing a bit more bigger and larger, such that the button you're trying to find is definitely the one you see the first. But nevertheless, here having the add minutes and the stop button is something people would not connect directly to each other in their mental concept of a microwave. And here having those two looking similar and also having them in the same region is not helpful in this case. Nevertheless, I would again emphasize that the Gestalt law of closure is the one that makes us connecting, for example, simple lines like the top line here and the right line here, and the bottom and the left line to one box. So this is creating a region for us where then the Gestalt law of common region is applying. I know this is a bit confusing at some point. One other Gestalt law, and then I think we can continue, by someone I have not heard today, and I think Hans, we did not have the chance.
Yeah, I wanted to add another thing. The start button is more or less disconnected from the numpad, and the numpad is basically the only thing you'll use together with the start button. So it would probably have been better to group the start button with the numpad instead of putting the stop, cancel, and add minute buttons closest to the numpad.
That's true, definitely. So at some point, this is also just because of usability, because if you think about the process that the user has there, he or she is entering a number and then directly wants to press start. So this should be close together. But also, those are probably those buttons you want to use together and want to use at one place. So placing the start button nearer would make this this concept a bit stronger.
Better ordering would likely have been to have the defrost and scan buttons at the top, then the numpad, then the start button, and then the ones that modify the current time.
Yeah, this would also work, yes.
that also kind of gives the user a flow from the top to the bottom in the order of things to be done.
That's correct, yes. Okay, Leonard, do you have a comment on that, or do you want to say another Gestalt law?
I want to add another Gestalt law, but it has actually just been typed in the chat, so it's actually a little bit redundant.
Okay, then I would say we continue. You can definitely, unfortunately, I cannot see the chat at the moment, but you can definitely have a discussion there.
Okay.
And otherwise, use the forum. We will check this. Okay. Oh, yeah. Sorry, my fault. We, of course, have also simple images here, but I think we covered all of them. Then I would say we can start with the next chapter, which is about information content. And information content is a theory about bits and bytes of user interfaces. So yeah, obviously you have already seen this for Fitzlaw. The measurement unit for this is bit. And at some point, we need to measure how complex, how much information our user interface has. In this lecture, we will have some more complex calculations with this afterwards in the second half of this course. But we do a first introduction to this today. So when we think about how to measure this user interface, we think about how much information does it have, and more or less this means how many states can our user interface have. So if we just look at a checkbox, and we can toggle this checkbox, it can be turned on or off. This can have two states, and we calculate the information content of this by simply saying, okay, two states is more or less 1 bit. A bit can be 0 or 1. So we have here an information content with one checkbox of 1 bit. And you can simply calculate this, putting the number of states into the logarithm to the base of 2. And this will tell you how complex, how much information is included there. Yeah.
So because those are checkboxes, shouldn't there be 2 to the power of 2 states? Ideally, there should be 4 states. Because
yes, if we combine the number of checkboxes and we say that they are not exclusive, then the complexity increases. So we have much more states, not only 4, but if we talk about checkboxes, they can have 4 to the 4 times 3 times 2 times 1. So the faculty of 4 states, and thus the information content of this would be increased. But this is something we will talk later about. And this you can also do for different things. So if you have, for example, a simple digit, this digit could be 0, it could be 1, it could be 2, it can be every number until 9. I hope this is clear. And thus we have 10 states. And if we want to know how much information this is, we put this into the logarithm again and have approximately 3.3 bits there, because 2 to the power 3.3, it's approximately 10. And again, we can do another step and do the same for letters. So if we take the alphabet and we have small and lowercase and uppercase letters, we have in generally for 1 character space 52 states, and there the information content of this could be 5.7 bits. This was now very simple for 1 checkbox or 1 number or 1 letter, but at some point we often see analog scales in our life. So think about, awaiting wait, what is the name? Think about your ruler or something like this, or the speedometer in your car. So how do you get the information content of such devices? And this, so because the number of states there is not clear, even if you have lower and upper limits. So for example, your car can stand still, or it can drive to 200 kilometers per hour, but nevertheless, it's not clear for us how many states a human perceives inside of that, how much he can differentiate this. And the only way to find this out is by performing experiments. And for example, giving a scale like you see here on the right, and to users, and ask them in which region the arrow is pointing at the moment, and identifying how many of those different positions they can distinguish. And one found out that in general, it's very easy to differentiate 8 different positions within the scale, and thus this interface would have 3 bits. We can do the same for very different things, for example, for audio pitch, for volume, or for saltiness. And when it's about the pitch, there we have an information content of around 2.5 bits. But of course, this is a very subjective thing. And if people have a perfect pitch, so they can identify pitches very good, those numbers increase. For volume, this is the same. So there, per experiment, we found out that this is about 2 bits. And for saltiness, by the way, I would love to see how the experiment looked like. Then we have 1.8 bits. There is a question, Tarek?
Could you explain the meaning of bits in this context? Because I understood it for the checkbox, but I don't quite get it here.
It's just about getting to understand the complexity of what you have in front of you. So if you have a simple user interface, the concept with the checkbox is pretty clear. So it can be on or off. But at some point, you can do this also for different scales and can measure this. So you can imagine you have an interface which creates some kind of saltiness on your tongue. Again, no idea how this device looks like, but imagine this this exists. Maybe it exists, I don't know. Then the question is, how many different levels of saltiness can you give to such a device? And here, this is again just, and how many information can you then communicate to the user by the saltiness this device is giving to you? And here, the bits is just, again, a way to measure this. And with the experiment, they found out that, we get around 1.8 bits out of this. So you can calculate this is less than 4 saltiness levels. If I don't confuse anything right now. So now you have seen the simple checkbox example. We talked about scales, and you have seen this analog scale here. What would you say? Would you prefer an analog or digital scale? What are the pros and cons of different scales? So having, for example, for the speedometer, having there, 4 digits saying you the velocity, or the speedometer as you know it from the, I think it's a standard interface. Yeah, Pascal.
I think an analog scale is very handy to get a sense of scale of the number you got. So you can easily see, is it something big, is it something small compared to what the scale is capable of showing. While a digital scale is more easy to get a precise reading because, for example, with a speedometer, knowing where the needle sits, you don't know if you're now driving at, I don't know, 47 or 49 kilometers per hour, which I don't know, in some scenarios maybe could be important. But you can easily see, okay, I'm still under the speed limit or over the speed limit without having to do a little bit more of mental arithmetic.
Mm-hmm. That's definitely all true. But first of all, are there other arguments, other opinions? Lennart, what's your opinion on that?
So I'd rather always prefer the digital scales, but you also have to mention that you don't overload the user with information. So for example, if we talk about volume on a radio, for example, the user maybe does not have to know how many percents of the maximum volume they are at currently. So it would a knob or something would rather be sufficient. But yeah, as Pascal said, maybe on speedometer it's important.
Yeah, I can agree. Other opinions?
I would say it depends.
Johannes, on what? On what does it depend?
It depends on the way you read stuff. For example, if you want to measure current, you would use digital scale to have more sufficient, let's say, readings after the dot, so you can read more precisely, whereas you would prefer an analog scale when you would go for pressure. For example, like on a pressure gauge, multiple people just mount an analog scale to, let's say, a bike pump, so you can see how the pressure performs. And it's implemented in several ways, but some people prefer analog scales in their, let's say, normal day life, and some people use digital scales for certain things.
That's definitely true. It is dependent on the usage scenario. So if you brought up the example with the voltage. So probably when you are measuring this, you want to measure to test whether you have a certain voltage at, for example, a pin of an Arduino or something like this. Then you definitely need to have clear numbers there. At some point, maybe you just are interested whether it is dangerous or not, and then an analog scale is also helpful in this case. So I think we collected the most important things here. Maybe we continue, and then you can tell me whether we forgot something. So as most of you said, in analog scales, we get the possibility to a quick estimate. We see the ranges from 0 to the max value. We can easily detect trends. However, as also said, it is harder to read them at some point, especially when you want to have a very precise result, where one has to say that it depends, of course, on the scale. So you could not easily say that analog scales are not as precise as digital scales, but at some point, it's just harder to read them. It depends, of course, of the device you have in front of you and the range. But with perfect eyes and zoom lenses and so on, probably you can have a very similar accuracy with analog scales. Digital displays, on the other hand, so digital scales, there you have probably a constant reading time, so you can quickly see, aha, this is 1 volt, for example, or this is 5 volt, and independent of how much the accuracy is there, the reading time is more or less constant when we think about scale, displays having just 3 or 4 digits and being able to show all of those numbers. Nevertheless, the advantages of the analog scales are, of course, the disadvantages of the digital scales. It is hard to estimate the trends. It's hard to estimate your location within the full range you have. You don't see how big the increments are eventually when the scale is not working on a one-digit basis. And you always need then labels for the limits. So if I'm not wrong, yes, this was a quick first introduction into information content. I can promise to you that we will continue on this topic in some lectures. It is just to give you, it was here just to give you the first idea of that we can measure the complexity and the information content of such user interfaces, and those matters for the human. So now, oh yeah, Janusz, you have a question?
I wanted to add something to the analog or digital trade-off, which is you mentioned for the quick estimate being kind of preferred for analog, but if you look at what the eventual goals are of someone, say with a bike pump, the example was, it is easier to kind of estimate on a thing with the analog, but if you take digital even more literally and just say on or off, if you just had a light that was on if you were at sufficient pressure, that would be even easier to communicate the information, and it's the only information they care about. I mean, depending on how particular they are about pressure. So digital can also produce an even more simplified view where you don't need heuristics.
Yes.
Just depending on the situation.
It's definitely always depending on the situation. It's I think Marcel also mentioned this very a lot in the lab, but as you said, the example, you can use digital scales to simplify the user interface. Nevertheless, in your example, also some information gets lost, because if you, for example, have not enough pressure in your wheel, and then you want to include, increase the pressure there, you don't know, having just an LED, how much more pressure you need and how long it will take to reach the green light state in this case. So it always has its pros and cons, and then you definitely have to check whether your solution fits to the situation where you want to use the scale.
So so I'll just like to add on to Janusz's discussion. Because he was talking about pressure, I kept on thinking about nuclear reactors and their pressure readings, right? So either if it's very low pressure, you can instantly understand that it's on the left-hand side of the meter. And if it's very high pressure, there'll usually be a red region and it's going towards that. So it's intuitively very easy to understand, okay, whether the reactor is at low pressure or whether it's high pressure. But if you digitize and quantize this information, that will be difficult. Essentially, you'll have like an indicator saying low pressure and it'll be beeping. And you'll have an indicator with high pressure that will be beeping. But they're not as intuitive as, say, a reading going towards the left or right.
Exactly. So with if you want to, you can definitely also implement a system which works on that way with a digital scale. So for example, you could have just the numbers and another indication light of, hey, the pressure is good and the pressure is not that good. But definitely it's, okay, I think I repeat myself, but it's definitely depending on the situation you are applying this interface to. Other comments on that before we continue?
Yeah, I think there are hybrid variants too. For example, if you're mixing audio on the mix poles, there are rows of LEDs where the lower ones are green. So they are vertical lines. Sorry, I missed that. And the lower ones are green. Then there are some yellow ones, and there are, for example, red ones, and they are monitoring the audio level. So if the audio is louder, then more LEDs rising from the bottom up to the top are lighting. And if the audio gets to a critical state where, for example, the audio perhaps is overdriving, you reach the yellow and eventually the red LED. So that is digital from the start, but the fact that there are multiple LEDs in a line makes it some kind of continuous.
Mixture, yes.
Yeah.
Yes, I definitely understand what you mean. And in this case, this is definitely a mix up of those both concepts to combine them. Nevertheless, I would say that we should now continue with the lecture. Are those important questions or just suggestions for other analog and digital scales? Okay, I think, again, I encourage you to write in the chat, to write in the forum and discuss your ideas here. How more you think about those concepts, the better you understand them. And I hope the better the exam will be. So also a short chapter about Hci literature. So when you want to look something up in the domain of Hci, there are some sources you can have a look to. One bigger thing are definitely conference papers. So most scientific work in our area is happening in papers, so it's presented on conferences, and there are a variety of conferences you can search papers on. So the largest and most prominent conference in our field is the Hci, which is taking place once a year, and papers submitted there are definitely high-class papers. This is also holding for the next conferences you see here. Those are the largest in our communities. First, the WIST, which is rather prominent for their technical contributions. There is the DIS, which is a design conference. The Interact is something you can definitely also have a look at, and the CSCV, which stands for computer-supported collaborative work, which is also a huge conference. You can find very interesting papers from and literature from. Also, the UBCamp and ACM Multimedia are very interesting. On the other hand, there are also journals like the Tokai or the Interaction magazine or the Puck. Those are just sources you can have a look at. And many of the papers of the conferences, the journals and so on, you can find them on the ACM Digital Library online, which is, by the way, you all should have access to if you are in the RWTH VPN. So if you are interested in some Hci literature, you can definitely have a look at there and read what is happening at the moment there. Of course, there are also textbooks about our topics. The most famous one, I would say, is the one you should already start reading. This is Donald Norman's book, Design of Everyday Things. This is teaching you about more or less everything you have learned until now in this course, but and some stuff you will learn, like affordances, mappings, and constraints, which will come up. Another very huge textbook is the textbook of DIS, the Human-Computer Interaction book. Also, it was your reading assignment, so you should have heard the name at least once. And there is the Designing User Interfaces of Schneiderman, now in the 6th edition, and Nielsen's Usability Engineering, which is definitely literature you can have a look at if you are interested in the topic. We, by the way, have a list of books online on our website. So therefore you can just go to our website /HCI books and have deeper look into a larger list of books and important work in this area. When it's about the Norman book, another word on active reading. So best in a good case, you should have a lot of margin notes in your books. You should have highlights, as you sent here, and lots of sticky notes. So this is here an extreme example of one of my colleagues here, René Schäfer, who definitely wanted, wanted me to show this in this lecture because he's a bit proud of this. And but this is exactly the way you should do it. Make highlights, make margin notes, which are not here on this page, unfortunately, make sticky notes such that you can quickly find the information in the book you need. So have around 1 or 2 key points per page on in the book. Make scribbles, make notes, just mark things with exclamation marks. If you have crazy associations, project ideas, any thoughts, write this into the book. In general, and the same with sticky notes if they fit better. But I would recommend use sticky notes for important keywords such that you can quickly find the passage in the book you are you're trying to find some information about. And if you're very encouraged, make summaries of the chapters. This is very, very helpful, but I think this is something we have seen rarely in our past. But if you do this, you can be sure that that you keep the things in the chapter in your memory in mind. So overall, I would say try to make the book as individual as possible. You should be able to recognize your individual book from meters away. And this then also increases some value you have to this book. This is something that you want to keep and to reference back all the time, and does not make a book afterwards just a decoration object in your home. So the design of everyday things is the ones you should read. As I mentioned, it's one of the Bibles in HCI. It's also very often cited in scientific papers, which is not the standard. So usually papers are citing other papers, but Norman's book is something you find very often, nevertheless. And originally this was published 1988 in the Psychology of Everyday Things. And yeah, I think I will repeat myself if I say it introduces important concepts like affordances, signifiers, and so on. Donald Norman has also other very interesting textbooks. Like Things That Make Us Smart, The Invisible Computer, Emotional Design, and The Design of Future Things, or Living with Complexity. All are worth having a look at them. So if you are really enjoying reading the book, and I hope it is, because it is also written in a very easy way, if you ask me, then you can definitely have a look at his other books. Okay, then after this, let's talk about visibility. And for this, I want to show you a quick video about, from a website called Web Pages That Sucks. But yeah, let's have a look. Sorry, do you have audio? Okay, I expect that. Wait a second. Then I have to stop my screen sharing for a moment. Next try.
It's not just small companies or music sites or band sites or sites that really don't count that use mystery meat navigation. Even big companies go stupid sometimes. And here's an example. Qualcomm. If you look up here in the right-hand corner, you see the mystery meat navigation. You have to mouse over this thing. Oh, now you can see what it does. Oh, okay. This is the latest news, and this is Ventures, and where was CDMA? Up. There it is. People are not going to memorize your navigation, and this isn't very impressive except to people who should know better. Don't use this technique.
Okay, I think this was clear. So one thing is we of course bring up some examples from time to time here, which are showing bad designs. And sometimes you think, yeah, this happens for the unexperienced designers there who create their first website and so on. And we now you're showing this off and blaming those people. By the way, never wanted to blame people. We just want to show you how to make it correct. But actually, this is happening a lot also for the famous brands. You just really have to have a look on this. And I think after this course, if you go there into the web and see the websites, you will definitely find some things which could be improved. And what you have seen there in the video is definitely an issue with visibility. So when you had this menu, which was moving all the time, and first of all, who of you have thought that this is a menu at first place? I definitely didn't. And then you saw that this is an interactive thing just when you were hovering with your mouse on top of that little moving icons and tried to find the menu point you are you're interested in. And this was a big problem of visibility there. And our mind is good seeing the world, interpreting the world. So your user interface should make use of this. So more or less what you should do is put the knowledge you need for user interface, for users to interact with that, put this into the world and don't let them learn how to use your UI. This can go horribly wrong. So visibility is definitely one of the very, very, very important things you have to pay attention to when designing an interface. Ideally, you don't have to put labels on something. The interface or the object you are designing is understandable by itself without the user to read the manual for this or to read every single label. So try to avoid that users have to think consciously about how to use whatever you are presenting to them. Make the design as natural as possible, and make also only the right things visible, because at some point, if you overwhelm the users with information, they cannot find the action they really want to do.
Okay, so Ollie explained some fundamentals of visibility to you, and here's just a wonderful example that I picked up many years ago in a hotel in Sweden, and this was a hairdryer that they had there in the hotel room, and it kind of, first reaction is this looks really neat, right? It's a cute little hairdryer, but as with so many things, this thing probably won a design award, and I like to think of design awards as warning labels for usability. So if something gets an award for really cool design, sometimes it actually goes at the cost of making it actually easy and efficient to use. Not always, sometimes they get it right, but this is not a guarantee. So this one, was definitely one of those, because you pick it up and you're like, this is a cute hairdryer, I love it. And then you flip it over to turn it on. So the first question is, how do I turn this thing on? And you can take some guesses here, what you think, what people might have to do. Some folks say, yeah, Marco, what do you think?
I was thinking of putting the thumb on this middle part and just flipping it up or down. That would be my guess.
Yep, that's a pretty good guess, actually. Shailesh, what do you think?
So I was thinking about, again, putting the thumb on it, but pressing the thing. So,
so pressing it down, right?
Yeah.
So other people think sometimes, you know, maybe this is something to rotate because this is groove for your finger to latch into, right? And it's actually, you know, flipping up and down. But think about this. We are talking about a freaking hairdryer here. We should not have a group discussion on how to possibly operate this thing, right? It should be completely obvious how to use it, and it should be completely intuitive without having to think twice on how to use such a simple device. So we're wondering how to turn it on. Next question I have, how many levels do you think it has? Again, you know, we could take a guess here. Maybe it is on or off. Maybe it has 2 levels, maybe more. We don't know, right? It's not obvious from the design. And this should not be something you need to think about. So I will show you, you know, finally, you know, this thing actually does have 2 levels, but how do you get to level 1 or level 2? Even if you know that you actually have to flip it up and down, and you know it has 2 levels, you still don't know which level is on which side or where they are, right? What's going on. So it turns out to turn it on, you do this. Now, at least at this point, you would say, okay, now I got the hang of this thing. So now I know how to get to level 2, right? By continuing to push. So that obviously the 2 will come right after the 1, but no. You know, to get to level 2, you actually have to go back over the 0's position and, you know, flip to the other side. So this, by the way, all these things are ridiculous, of course, but we have very clear concepts that this design is breaking. So we can talk about what's wrong here in quite informed terms. And that's the first step, right? You have to name these things and find concepts that they are breaking or following so that you can do a better job. And what I'm trying to show here is that this hairdryer is breaking the 3 most common questions that people ask themselves whenever they interact with technology. Question 1 is, what can I do here? This would be, in the hairdryer case, the question of how many levels are there, right? And that's not obvious when you pick this thing up. Second question is, if I know what I can do here, how do I do it? In this case, how do I get to level 2 once I know there are 2 levels? Again, here the interface is not showing you how to do it. And in fact, it's not just hiding it, but it's also using a highly non-intuitive layout so that your guess that you ultimately might make without seeing any cues is probably going to be wrong. And thirdly, the question that a lot of people all the time ask themselves when they interact with technology is, what state is this thing in right now? Where am I right now? And what's the current state of the device? And in a case like this, if you pick a hairdryer up and it's showing you what you're seeing on the screen right now, would you bet your life on whether this thing was on or off? Would you toss this into your bathtub and say, oh, I'm sure it's off? You know, probably not, right? So the current state of the device is also not entirely obvious. And these are the 3 things. Where am I? What can I do here? And how do I do it? These are all things that this hairdryer design breaks. Now, just for, you know, a minute, I want you guys to take your piece of paper and improve this hairdryer. So what would be a good design for a hairdryer that would not have this kind of, you know, these kinds of usability problems? And you don't need to get fancy, right? You don't need to put AI into your hairdryer, really. It's not necessary. It's a very simple device with very simple functions. So pick up a piece of paper and sketch how you would design this switch that we just saw, how you would redesign that instead. Just take a minute to do that.
Can you hear me?
Yep, hear you fine.
Okay. I would just do one button that you can slide up or down, and next to it you have a 0, 1, or 2. So in 0 you have off, in 1 you have obviously on, and in level 1, and on 2 it's level 2.
Yes, so that's definitely a way to go. You want the button to be the one switch or button that you can slide up and down, you know, because then the movement is natural. and you want to show all the positions. Tanvir, what do you think? What's your design?
I was thinking the same thing about button. Besides, we can use a rotation type screw where it indicates 1, 2, 3, 4. The one side is going to be heat and one side is going to be cool.
Yep. Yeah, so that's another one. The most natural one that you could probably come across, that you could probably do, is the linear up and down, and we'll get to why that is the most natural one in just a second. But rotation is often accepted as a proxy for adjusting a value to be more and less, and we typically rotate right to make it more and left to make it less, like your typical volume control on a radio, for example. Shailesh, go ahead.
Yeah, so just adding on top of what these two guys said, but I'll use this linear thing with a button in between, which is the off state, which signifies 0, and hot is up, and you have 2 levels on hot, and you have 2 levels in cold. So if you go up, you can go either 1 level hot or 2 levels hot, or if you go down, you can go 1 level cold or 2 levels cold, or something like that.
Okay, so what you're designing is already a more complex hairdryer, right? The hairdryer we're talking about here doesn't even have those levels. And I wasn't asking you to have this in there. It's a very common thing for computer scientists and engineers to go, I'm going to get some more features in there, right? No problem. But for two things, this is interesting. First of all, once you've added some features into it that we weren't explicitly asking for, and that's often a trait of engineers. So be careful about those things unless you really see that it is needed. And then secondly, if you do add those, if you have hot in one direction and cold in the other direction, that will break a rule that we call natural mappings, again, which I'll talk about in just a minute. Oh, Kevin, go ahead. I see your hand up there.
Yeah, I wouldn't actually use rotational knob for this, because hairdryers you normally want to use with one hand, and for something what you want to use with one hand, you can't operate it. Oh, sorry.
Yeah.
A rotational knob you can't operate with one hand. You always need the underhand to rotate it, and the other to
excellent point. Yes. So you're bringing up a very good point, which is even with something as simple as a hairdryer, we have to think about the context of use. And the context of use is usually I'm holding this thing behind my head and I have one thumb free to operate it, right? Ideally, turning it off and on as I need it. And in that situation, a rotational knob is actually really hard to operate, whereas a linear slider that you can slide up and down is also a little bit more ergonomic and could work well hands-free. Also, when you're using this while you're not looking at it, that's called eyes-free use. And this is, again, why it's super important to have a natural mapping of the different states of level 1, level 2, being, going up each time. Simply because this is so easy to remember, then you don't have to think about it. And if you don't have to think about it, you don't need to look at the display again. You will just remember it immediately and do it right without having to think about it very much. There's, I think Tanvir, I think we've already heard you. So I think Eric was, and Henrik were just added to that. I think Henrik was first, sorry. Sorry, Henrik, you want to go ahead?
I'd redesign the handle too, because it's almost ball-like and it seems pretty big. I don't think a person with small hands could reach the button with one hand.
Very good point. Very good point. So with these physical devices, we need to keep questions of ergonomics in mind as well. And the example I was giving with me reaching behind my head and using my thumb to adjust something is one of those examples. But exactly what you're saying, right? The reach of the average hand and the question, can I actually grab around the handle and still reach that button comfortably, is another one. Very, very good. That's why, the iPhone 13 Pro Max is awesome, but there's no way I could possibly hold this in my hand and still operate the screen at the same time. I don't have a thumb that's long. So unfortunately, no Pro Max for me. Okay, now Eric, now is your time.
Hi, so I think that it could be unnecessary to use first level when users needs the second one so rapidly. It's probably a good idea to put it in other sites, from zero level.
See, there you go. So that you're bringing up a valid argument, which is, if I wanted to go to level 2, why do I have to go through level 1, right? And I would tend to agree, especially if the operation of getting to level 1 is kind of, mechanically arduous or complex or complicated or just, takes effort. If you have a slider that goes directly from 0 to 2 and it just slides over 1 with a little notch in between, I think that's fine, right? Because it keeps the natural mapping of these levels in place, and that's a really important design guideline. Plus the notch at level 1 would give you a haptic feedback. Again, we're going to talk about feedback in more details, that you have actually now passed level 1 and that you're now going to level 2. So while you could put these two on the opposite sides, like the Swedish hairdryer did, I think what it's doing is it's breaking a fairly big usability law in order to get some very minor, you could call it efficiency improvement of not having to go through an intermediate level. Tarek, go ahead.
On the topic of the handle, it's pretty obvious by the direction the stream is going in, but with a convex ball, it's like you don't know where the direction is pointing at. But if you had a straight line and the concave thing, like you had the straight line for orientation where the back is, and you can grab it on the concave part, so you can like grab it with your hands, I guess.
Okay. Yeah, so all of these are right. And as you can see, this is as simple as a hairdryer that we're talking about. And already we're discovering all these interesting things that you get to only when you think about it more deeply. And another thing we will learn is that there are probably other things we haven't thought about that we will only learn if we actually observe people using a hairdryer. Now, we all use hairdryers, or most of us do. So we are actually, we know how these things work, and we can kind of put ourselves into the shoes of using a hairdryer. But especially if it's something that you're not a very, very avid user of yourself, then it's super important to talk to people that use the device or that are supposed to use the device that you designed, because you will learn about things that you didn't actually think about. So that's why we always include user observation, watching people use the technology we're designing or we want to improve. And we include talking to those people, interviews, etc., in order to really triangulate and really narrow down and understand the subject matter, the context of use, the task, the problems with usability. I'm sorry to say this, dear computer scientists, but it does involve talking to other people. So that's in there. All right, now enough about that. One more thing I want to actually mention is an important layout detail that a lot of modern interfaces, including, iOS, whatever, get wrong, is that when you design a slide that is supposed to go to multiple levels, let's say we've got, a slider that goes to off level 1 or level 2. It's extremely confusing if you put the label 0, 1, and 2 onto the slider and somehow hope that people understand what that means. What you want is you want the label off 1 and 2 off to the side, and then you want, your slider being that little arrow pointing to the off or the 1 or the 2. There is no way you could misunderstand that, right? If I have a slider that I move along 3 notches and there's a little label next to each other, off 1 and 2, everybody will know how many levels there are, which level the system is currently at, and how to get to each level, right? We've answered all these 3 questions perfectly. If, however, you take, for example, iOS 15 and even, many earlier versions, and you got these little slider buttons, that are supposed to tell you whether something is on or off, they don't have any label. And if they do have a label, the label is put onto the button, which is highly confusing, because what does that mean? Does the label on the button mean this is what's going to happen if I press it? So does it describe the action the button will trigger? Or does it describe its current state, which is what is going on right now, which the button will then change? You've all been there. If you've ever seen a switch on an electrical appliance, where one side is poking out, and on the side that's poking out, it says off. You're like, well, is it currently off because I'm seeing the off? Or is it currently on because I can see the off to turn it off, right? It's unclear. And so to this day, interfaces make this mistake everywhere. In the quest for saving a few pixels of screen real estate, Even those sliders that you see in modern operating systems are often designed really badly and leave this, questionable. And it gets even worse if these switch buttons, these toggle buttons, then get reduced down to a single field that is somehow trying to illustrate both the current state and what you can do to it. Take things like, I don't know, dark mode or do not disturb, right? They become icons in like gray on dark gray. And if you press them, they become an icon that's dark gray on gray. I don't know which one of these means it's active and which one means it's inactive. And I don't know whether I'm seeing the current state or whether I'm seeing the action that this thing is going to take. So this reduction down to less and less screen real estate is extremely toxic for usability. So be careful of that. Now, so those are a couple of things you can fix, right? You detach the label and the control. This is a fundamental rule. If you have that space at all, detach it and your users will be happy. You need to provide an overview of possible settings. What can I do right now? And you need to design the knob to show how it can be used, like push, slide, rotate. And finally, you want to make sure that the current setting of the control against the scale is easy to determine. I know where I am, right? So you take a super easy, simple design like this one here. Oh, natural ordering of settings, for example. This is a cheapo hairdryer, and it uses this simple slider that has these 3 levels. And it's very easy to understand what current level it is at and how to operate it. We talked about already that this is all fine for a new product, but we need to think about the use case. We talked about one-handed operation already, but also your labels, if they wear off after a few months, then they kind of become useless. You need controls that don't short out and kill you when you touch them with slightly moist hands. Some hairdryers get used in different countries, so they may need a voltage setting. There's lots of things that go into even a simple product like this. And as you go through all these extra design constraints and extra thoughts that you have, remember to keep the first rule of UI design in your head, right? Keep it simple. The example that we had earlier with, I'm going to add, 2 hot and 2 cold levels to it. Yeah, you can do that, but only do it if it's really what your user base is explicitly asking for, right? Now, if we don't provide visibility, if we're not good at doing this, then a couple bad things can happen. First of all, if I can't see exactly what's going on, then I will make up my own cause and effect explanations. So if I lack the visibility, then it can cause false causalities, thinking your action has, a bad effect or no effect. You'll probably have heard about these examples, right? Your mom or your dad might call you and say, I don't know, I just turned on my printer and then the internet broke, right? And as a computer scientist, you're like, yeah, I know that's not probably what's going on. But for them, that was the cause and effect because they don't have enough visibility in the system that's clearly telling them what's wrong with one system and what the other system is triggering. These things can easily lead to, superstition and false causalities, and it's ultimately loss of control and a loss of feeling that I'm in control of the technology around me. We've all been there, right? You've probably, you've used an app at some point on your desktop maybe, or on your smartphone, and you click once, nothing happens. Then after 2 seconds, you click again, still nothing happens. And then you click like 15 times really fast and really hard, right? And hope that changes things. That's us assuming that, the system hasn't heard me the first time, but we don't know. And sometimes it has heard you, and then all those 15 clicks go in and suddenly you bought, the collected works of William Shakespeare online without you ever intending to. So all these things are really bad for usability. So we need to keep visibility up, right? Otherwise people start misunderstanding our interface, misunderstanding what their impact of their actions are. And I don't know whether you guys still did this, but when I was, back when I was still burning DVDs and CDs, I would sometimes, touch my drive ever so gently when it was writing a really important CD, because I thought, well, I think that's, keeping down the bad vibrations and making the write more successful. And those kinds of things, happen. But yeah, I'm probably just showing my age when I'm talking about spinning media here. Okay, so this is all about the psychology of one person using a device. But of course, there are market constraints, right? And this is what this is an issue that Norman already writes about, and this book was first printed in 1988. And even today, we're still facing that problem that if you say, we want to make sure this thing is easy to use and it has the best user interface we can possibly come up with, a lot of people are like, well, is that going to sell it more? And then you have to start arguing why it's a good idea to improve, improve usability. And part of the problem is consumer behavior, of course, right? I don't know whether you've been to this, but sometimes when you go to, Saturn or MediaMarkt, right, and you see all these, I don't know, TVs up there, then a lot of people fall into this zombie mode where all they're looking for is how many little dots do I get on that little, info card below the TV? How many features are the bullet listed there? And how expensive is it? And then people are like, okay, this TV is, $1,500 and this other one is $1,600, but I get, let's see, 3 more bullet points with features. Not sure what they mean, but I'm going to go for that. 3 features for $100. That's a great deal, right? This is, of course, extremely self-destructive because you get home with this TV with all these features, and then you find that you don't actually need them all and that they complicate the user interface completely needlessly, and that you need to press 15 buttons just to, turn on the TV and watch a movie. So there's the difference between the purchasing decision is often guided by price and feature lists, because usability oftentimes is not regarded and is not reported well in the product description. Most products are being sold through features, and that's what's being marketed. And that's wrong, right? So you don't want features per euro as your quality. You want actually user experience and usability per euro as your primary thing. Because what am I going to get out of a device that has lots of features that I don't use, but that makes it unnecessarily hard to use the things that I do want to use? So, but we can start addressing this, right? First of all, taking classes like you do now, you will become people who will walk through MediaMarkt. This actually happened to me one day. I was walking around in MediaMarkt and in the smartphone section, and suddenly I heard a discussion in the next aisle down. And one guy said, look at this cool new smartphone here and the UI, and the next one said, oh, but I don't know, check this out, it's, that's actually not good visibility of the most important features here. And look, this is, that's even breaking Fitzlaw in terms of where the buttons are positioned. And I was like, wow, this is awesome. Well, then I walked around the corner, and sure enough, it was 2, former DIS1 students who were talking there. So on the one hand, I felt happy I had succeeded as a teacher, but on the other hand, I was a little sad because they're probably the only people who say Fitzlaw in the halls of MediaMarkt. Anyway, these things apply to all the kinds of interfaces that you will encounter out there. And we need to make sure that once you leave this class, you will become nitpickers that notice bad, but also good user interfaces everywhere, from your toilet stall in the hotel room all the way to the latest release of Windows or Mac OS or Android or iOS. All right. Companies are picking this up, right? So Philips used to have this extremely lame, if I may say this, tagline that said, let's make things better. Yeah, like let's make things worse would be a valid tagline, right? Okay, but they actually changed this, and it actually became more about users, right? So this was the change thing, sense and simplicity. And I love that, a company as big as Philips was actually picking up on the sense that things need to actually be simple to use and appropriate for their tasks and not unnecessarily complex. And they've changed this again, and it's now an innovation and so there is still the user-centeredness in this, although in a different way. But let me show you a couple more hilarious examples of user interfaces. And I'm sorry, most of these are going to be bad user interfaces because they're so much more fun to look at and to make fun of. So I'm going to start with our old telephones that we used to have at RWTH until just basically last year. This was the telephone system at the university, and many labs actually still have this. And the question is, how do you check your voicemail? Does anybody have a suggestion on how you would check your voicemail on this system? You got to look closely, I think. Yeah, Marco, go ahead. You go first.
I see right, like at the left part, right above the keyboard, I see this, well, like the 2 buttons is playing like something that you can as if you can change audio, as if you can talk. So I can imagine the one with like the audio is like you listen to what people said, and with the talking icon is like you send a voicemail to someone. I guess that's my assumption.
Oh, okay. Wow. Okay. So congratulations, because that's the first time I've heard this, and I've had this picture in the slides for many years. That is extremely original. Thank you. It's not the right answer, but never mind. The other answers are going to be wrong too. So I think Pascal, you were next.
My personal guess would be the letter button on the right side above the keyboard.
Right. There's an envelope there, right?
Which is probably wrong, but
yes,
that's the best guess I have.
So thank you. That is actually the answer that most people will come to, that there's an envelope button, and that is probably going to trigger your voicemail, right? I'm going to zoom in here so you can see it more closely. This is what it looks like, right? There's an envelope button in the middle. And of course you would think, okay, that's the one that I'm going to press, right? But no, it's much easier than that. You just have to dial *71 to get to your voicemail. So that's ridiculous, of course, right? And not only is it easy to miss the right clue, to miss the clue that's there, but then if you find the clue, the button with the envelope on it, it's actually wrong. So the reason for that, of course, is that, when these things were installed, and probably somebody skimmed on the extra feature list that they bought from the supplier, and then they had to go with the numerical shortcuts for all these advanced commands rather than actually using the buttons that are on the phone. These phones have more, had more entertaining things. Like, for example, you would call somebody and it says, press 1 for this, press 2 for this, and you would press it, and weird stuff would happen. It would not do what you would expect. You actually had to activate tone dialing first. If you didn't, then it would disconnect you from the call as soon as you pressed another number. And you had to press *8 to activate tone dialing. Very obvious, right? When you retrieved, you had a list of missed calls, but you could only retrieve each missed number exactly once. If you stepped over it and tried to go back to that number later, it would be gone. This was, I think, in response to some pretty weird privacy requirements that were made from the staff representatives that didn't want old numbers to be stored in there. But of course, it completely ruined the feature and made usability horrible. So you were actually sitting there and pencil copying numbers from your display, from a digital display, in order to know who called you, which you then had to type in again to call these people later. Completely ridiculous. And mobile phones are not often much better, right? For example, if you've ever tried to block your caller ID, until smartphones came around and had this as a menu option, you often also had to type in like * something to make these things happen. So here's another example. And this example will lead us to an important concept. I think we're going to probably march through Ollie, right? We only have 50 minutes left. We'll continue with the material here at this point.
I think Affordances will work out the conceptual models not.
Yeah, that's fine. I think that's a great break. We'll do it that way. Okay, so let me tell you about British Rail shelters, right? These little booths that you could wait for the bus under. These things were originally designed with glass walls, as you see in that picture here on the right. And they were being vandalized routinely. Well, one reason why that was going on was because glass looks extremely fragile, right? Glass looks like it will break easily. We all think, we see a pane of glass, we think that'll break easily. Normal people think I got to be careful not to break it. And some crazy people think, oh, this should be a lot of fun to smash in with my boots. And so these things got kicked down a lot and were broken. What was going on was that glass as a material has an affordance. A sheet of glass, a pane of glass, suggests that it will break easily, right? So, and some people then pick that up as, an invitation to break it. Now, British Rail caught on to that. They actually replaced these walls, these glass walls, with walls made from plywood, Sperrholz in German. And they were just as strong. They were no stronger than the glass walls earlier on. But guess what? The demolishing stopped. People stopped kicking them in, although it would have been just as easy to kick them in. But they weren't suggesting to be kicked in as much as a glass pane was. Right? The affordance was gone, the affordance to break them. However, then people started to scribble on them like crazy and put graffiti on it because, those smooth surfaces were suggesting to write on them, right? So this was because the wood was suggesting it was looking more stable and robust and supporting. And so it was less inviting to be broken down. Hans, go ahead.
Would you say the concept of glass being easy to break is because it's transparent and most often rather thin, or would you say it's specific to glass? So if it was an acrylic pane, would it be different?
No. I think it's the first thing you said. Thin and transparent to us suggests, easily broken, right? Because we've all seen glass break when if we drop, a drinking glass or something. This is basically personal experience, and everybody knows that glass is a fragile material, and that's why it then translates and is mapped onto these panes. So even if they were made out of some super robust glass, people would still try to kick them in just as often because they think, well, that's going to break. They may not break then if you make them out of some super strong material, but the affordance would still be there to try to kick them in. In a way, a super robust glass pane would actually be a false affordance, but we'll get to that in just a second.
All right, thanks.
Thank you. That's a good point. So affordances, I've said this a lot now here. Oh, Ziyong, did you have a question, or is that still an old hand up there?
No, it is a current question.
Go ahead.
With regards to the glass and replacing it with wood, wouldn't that reduce functionality of some sort? Like, I imagine if it were raining and you wanted to run to the shelter to try and find rain, you wouldn't be able to see whether there were people underneath.
Yeah, excellent point. Of course, changing from glass to wood changes the way that this shelter can be used and will be used. It'll change some patterns about people and might be a worse solution. That might be why they originally went with glass. I don't know. You're right, being able to see whether somebody's at the stop or when I'm standing inside it without having to step out in the rain, seeing whether the bus is coming, all these things are super useful with glass walls. I was just referring to this one aspect of glass having this physical affordance of being broken quite easily. But it's a wonderful example because we can't just rely on this affordance to answer all the questions for us. Design, and I hate to break this to you guys, I know you are technically minded, design is always going to be a compromise. It's always going to be some dirty in the middle solution that is balancing priorities and finding some middle ground that so solves all the issues we have. Very rarely are you going to face something where you say, this is exactly how it's going to be, and that is ideal from all aspects. It's not what's going on, unfortunately, in design. So be prepared to compromise a lot when you design. So affordances, this is, however, a concept that is really important and quite central to this first part of the class, is a concept that was originally developed in environmental biology. Originally, affordances meant what an environment offers an animal. So for example, if you are an animal in the desert, there's just sand, right? So what does that environment afford? Well, it offers the opportunity to dig yourself in. And so animals adapt to that and start, developing strategies and survival strategies that include digging themselves under sand. Now, Don Norman, in his book that you are reading, took this from environmental biology and applied it to human-computer interaction. And he said, for human-computer interaction, affordances are the actions that an object allows a user or even suggests to a user to do with it. So here's the quote from Norman's book: an affordance is a relationship between the properties of an object and the capabilities of the agent, that's your user, that determine just how the object could possibly be used. Note that affordances may not be universal, right? If the agent has different capabilities, then the affordances may mean something else to them based on what they can do or cannot do. So affordances depend on both the object and the user. Right? A chair, for example, typically suggests sitting, right, for pretty much everybody. I think even if you showed a chair to somebody who had never seen a chair before, they would probably quite soon, use it to sit on it. But it also affords other things. So if you're used to doing lots of home improvement, and you see a chair and it suggests to you, I can stand on this, hopefully, if it's not going to break. Now, affordances themselves are usually visible. So you look at something and you can perceive the affordance. The affordance is right there in front of you. But there are also hidden affordances, which we'll get to in just a minute. Now, going along with affordances, and this was a later addition of Norman to his model of affordances, that, I will be honest, doesn't exactly make things easier to talk about, but it is an important distinction, especially for software user interfaces like touchscreens and so on, or even desktop user interfaces, where you render things graphically. So, because a touchscreen, all it affords is it's a black square, right? So if you have never seen a touchscreen, then it's not going to afford anything to you. It's just a black square. If you've used lots of touchscreens, then it's going to mean to you, I can touch this. But that doesn't tell you yet where and how to touch what for what effect. For this, you need signifiers. And signifiers are the so-called signaling components of an affordance. So they signify the affordance. So the affordance says what action, like touch, and signifiers often say where, which button to touch, what gesture to do. And for design, signifiers may actually be the more important thing to think about than affordances. There's a simple case. Well, I should say maybe why signifiers were introduced by Norman was mostly because he found that lots of designers were misusing the word affordance in his understanding. They were often using affordance to indicate, where a particular user action had to take place, and that's why Norman introduced this extra concept. In a simple case, a perceivable affordance is its own signifier. So, for example, if you have a blank metal plate and there's a big red button on it, then you don't need signifiers. The button is there, the button affords pushing, and it's its own signifier. You don't need to do anything else. But if you have a touchscreen with lots of icons on it, then the touchscreen would be, providing the affordance to touch, and those various buttons on the interface would suggest where to touch and how to touch there. So whenever an affordance is not perceivable, like for example, the touchscreen actually is not by itself showing you, where and how to touch it. It's just, if you know a touchscreen, you know that you can touch it. Then that's why you need to add a signifier, like a button, for example, on the screen to actually tell the user what to do. Here's an example from an early version of iOS. On the right-hand side, you can see there's the touchscreen of the smartphone before it gets unlocked, right? The iPhone is still locked. And there's an animation at the bottom that will play once I click this button here. And this animation was there as soon as you pulled your iPhone out of your pocket and tried to unlock it. It would do this, slide to unlock. See this almost like a flashlight, like a spotlight going across. And that's a very nice way of visually showing me what to do, right? It says slide to unlock. Okay, I know what to do. And with this graphical animation, I even know now, okay, I guess I'm following the light, right? I'm going to do it that way. So this is an example of a signifier in the interface where the affordance is the touchscreen. The signifier is this animated slide to unlock button there. Now, I said that things can, affordance signifiers can be intentional and unintentional. An intentional signifier is, for example, any kind of sign. For example, a door sign or a button that says, click here. I'm sorry, Sarah, there was a hand up. Did you have a question?
Question regarding
okay.
The button example, but I think it's already answered on this slide here, because you mentioned affordance regarding the button, that the human being can already detect that a button has the affordance of being pushed. Mm-hmm. But I wanted to ask, so if I were to add a description such as, like, for instance, click here or upload or whatever, that is considered mm-hmm. to be the signifier. I just wanted to make sure that that's the case to better understand the distinction between the two.
Yeah, so I would say yes. Whereas if you actually have a touch screen, for example, then the button in its entirety with the labeling on it would be the signifier, because it tells you where to touch and what to do. And as with many things in these models of how humans think, these things are, again, bad news, not entirely black and white. So you'll find a bit of leeway in interpreting something in one way or the other. We don't always have the one correct answer on how to apply these labels of signifiers and affordances to something. But that's not the point, right? It's not supposed to be mathematically precise. It's supposed to be a thinking tool to help you understand how interfaces work and why something might work or might not work. So here are some examples of unintentional signifiers. You know, you walk along a snowy path, and all of a sudden you see these footprints in front of you. And those are signifying to you, okay, this is where I can walk along this, you know, ridge, obviously, because other people did it, and apparently they didn't die there because the footprints continue. And they never planned to leave these for you. They were not designed, right? They were just there from use. Or, you know, if you have a flag that's flying, to, you know, I don't know, to show off the country that you're in, and it's also flying, you know, it's being flown by the wind, and you can also tell the wind direction from that, although that was not its original intentional design. Either way, whether signifiers are intentional or unintentional, and this is important, users will interpret them as a pretty strong cue as to what to do, right? So as a product designer, you can use these things, affordances and signifiers, and if you use them well, you can really support great design. The easiest one, should be clear by now, is the perceived affordance, right? That provides a super strong clue. You don't need any instructions, any extra labels, any extra signifiers. The affordance explains itself, so to say. And this actually, in an extreme way of thinking, you could say that any design that actually needs labels to explain itself may be a bad design. It may not be necessary to have labels if you do the design in a better way. Now, this is also true for many software UIs, not everything, I'll be honest. If you have you know, a tool like a video editing tool with millions of functions in there, it would be ridiculous to try to represent even the most complex functions with little you know, buttons that are completely self-explanatory, even without a little, you know, piece of text on them. So a lot of complex and abstract functions, like, you know, reformat this paragraph in a Hebrew font or something, those things will be hard to represent in a simple graphic that is immediately apparent. So in many software UIs, you can replace a lot of things with perceived affordances, but for some things you will still need signifiers and buttons that are labeled. So we're just trying to make it as easy as possible for the user to pick up a lot of things automatically without having to read labels or other instructions. Here's an example. This is a headlamp that I picked up for rock climbing. And I thought this was pretty nifty. And I figured, okay, so the way to turn this on is obviously to turn these little flaps on the side, right? You see them on the right-hand side, because if you turn it on this way, this looks like you need to turn it that way. But if you look closely, actually, that's not what you want to do. If you try to turn this while you're, you know, climbing 100 meters above ground, and you turn this right-hand side, what's going to happen is that the battery compartment opens and your batteries fall out and tumble 100 meters down into the abyss. So that's not good, right? This thing is strongly suggesting to turn it, but what it does is it actually opens the battery compartment, which you probably don't want to do in everyday use. And the other side, then you might be, okay, so maybe I need to turn the other side to turn this thing on. No, and apparently so many people tried to turn it and broke this lamp that the manufacturer actually, if you see this, printed "don't twist" in between these little flaps, which is just ridiculous, right? It puts these awesome flaps on there, which are perfect for holding on to them and twist, giving this thing a good old twist. And then in between they print, that's not what you're supposed to be doing. So that's terrible, right? This is labels trying to fix a design that created affordances that were strongly misleading. So that's not how you turn this thing on or off. In fact, what you need to do is to press this extremely inconspicuous black button in the middle of the side of the headlamp. It took me a while to figure that out. When we are in physical, in-person meetings, I often hand this thing around and nobody figures out how to turn it on until they played for it for quite a while. Not a great design. Doors feature prominently in Norman's book, so much that he actually complained at one point that he has now become known for something that's called the Norman door. And the Norman door is a badly designed door, and he hates the fact that that's associated with his name. But hey, that's the price of being famous, right? So doors like this, what do they suggest? Clearly, you've got big flat fields that just call out push me, right? But this particular door doesn't work that way. So you actually have to pull that door. And that's why they had to add this label pull, so people wouldn't try pushing it. Well, most people would still probably walk up to it, push it, fail, and then see, oh, okay, I have to pull it because the label says so, and then they pull instead. But it gets better. This particular door, actually, you pull on one side, but you do push on the other side. So on the other side, they put the label back in that kind of duplicates the natural perceived affordance of that flat area there. So that's just ridiculous, right? Here's another one. This is an IKEA shoe wardrobe. And clearly the way that this handle is mounted there at the top, it suggests that you need to pull this and it's going to open up to the bottom, right? That's what this, it's like a dishwasher. That's what you would expect from the way this handle is mounted. But no, if you pull this, and you will actually pull it a little harder because it's in a mechanically bad position, it actually opens to the side. Again, not what you would expect, right? And this is so easy to fix, right? You would just have to put the handle over to one corner of the lid there, maybe even turn it around by 90 degrees, and then everybody would expect it to open just like a fridge, right? Because that's what this is doing. So what we're seeing here are false affordances, accidental affordances, and misleading signifiers. First example of that door that had this flat panel to push on, that was suggesting to push, and that was a false affordance. It needed to get fixed by adding a signifier that says you need to actually pull, adding a label here. The second one is an example here from a staircase that has this little ledge on the top. And as you can see here, the top window, top picture, the ledge is empty, and then the middle picture shows one Coke can, an empty Coke can standing on there, and the bottom picture shows lots of empty, coffee mugs and paper cups standing on that ledge. That's an accidental affordance because that railing just invites you to leave stuff on there, right, of the size of a typical drinking cup. And that's not very helpful because these things can fall down and then they splash and they make a mess or fall onto people's heads. So you don't want this. On the other hand, if people sit on that staircase, that's actually a helpful thing because that will suggest to others, okay, so that's also a possible sitting place here. Unless, of course, you're blocking fire exit. And finally here, you can see this handle that was put at a particular point on this shoe cupboard here actually was also not suggesting the right action. It was suggesting where and how to operate it, but it was misleading. So that would be probably more something of a misleading signifier. Now, you will find, and with this I'll wrap up for today, you will find that these things are confusing. Sometimes you will find something that looks more like an affordance. Sometimes you'll find something that looks more like a signifier. So be aware that these things are not always entirely clear cut. I will skip over the conceptual models for today. We'll do these maybe next week. Ollie, we can just tag those onto that unless they're needed for the lab. You'll have to check on that. And let me jump right to the summary here. What I wanted to mention before I let you go for today is that you need to start reading Norman's book. You should be reading this until page 36 this week. You overall have only 4 weeks to finish it completely. So as of for this moment, we're already 12% in the book. So keep up with reading this. Don't leave that until the midterm or anything like that. And then what we recommend you read, you don't have to, but I think it really casts a nice additional light on the question of these theories and how the human mind works, is on one hand the chapter 3 by Alan Dix and his colleagues from the Human-Computer Interaction textbook. That chapter is called The Interaction. And then there is Schneiderman's book, Designing the User Interface. This is the third big book in HCI that everybody knows about. An excellent book that collects a lot of up-to-date work in various areas of HCI. And it has a great chapter on theories in chapter 2.4. I want you guys to take a look at that as well if you're interested. Not a required reading. We won't grill you on these specific pieces of information in there in the midterm or final, but they will help you to understand the material better. The reading assignments will be on Moodle, these recommended ones. The normal book, of course, not, because we need you to read that in its entirety. All right, with that, we're wrapping up for today. Thanks everybody for listening. Sorry I had to drop out in the middle for a bit. Thanks Ollie for stepping in, and good luck with the assignments, and I hope to see you again next week.
This content was provided by RWTH Aachen University.